We're going to look at phase shift, which is the horizontal shifts left and right. So when we look at the general form of a sine or a cosine function, we can look at the input and the number that's being subtracted from our input, that C value, that is the phase shift. And that is how much our original sine graph has shifted right. Okay, so if we're subtracting a number, the number that we can see there is the phase shift. But it can be confusing because the input doesn't always have the B factored out. So what you can either just rewrite that in factored form, or just take and divide your K divided by your B. All right, so in both of those cases, there's how to find your phase shift. Okay, so let's look at a few examples. Here, there's nothing factored out, but there's also no coefficient in front of the x. So we don't need to worry about the factoring and the dividing and all this stuff. Okay, we can just look at this. The amplitude is 1. The period, there has, like I just said, there's no coefficient in front of x, so period is just the original 2 pi. But the thing that's going on here is we have that plus pi. Okay, and note that sine of x minus a negative pi would simplify to that x plus pi. So in the general form, it's x minus the phase shift, okay? So the phase shift is negative pi. There's my phase shift. Okay, so what that means is my original sine graph has shifted left, because it's negative, by pi. Okay, so we can look at our original sine curve. That would be y equals sine of x, and we can just pick that up and just move it left by pi units. Sometimes that can be a little bit hard to figure out what those points are, so generally I find it easier just to think about the start and the end. Okay, an original sine starts at 0, ends at 2 pi, and so those are going to be my start and end, but now I have a different input. Okay, instead of just x equals 0 for the start, now it's x plus pi equals 0, and then x plus pi equals the end equals 2 pi. Okay, so just take your input, whatever it is, and set it equal to 0 and 2 pi, and then solve for x. In this case, when we subtract pi from both sides, you would get x equals negative pi is your new start, and x equals pi is your new end. Okay, and so then we can just see where those are. Here's negative pi. Okay, so what my graph now does is it starts at negative pi, and now it ends at pi. Okay, and so now I go from negative pi up to the peak, down to the midline, down to the bottom, and back to the midline. So there's my new graph, and it's just slid left. And we want to just think about what are our key points there, and E. So we started at negative pi 0, that's the first key point A. This one would be negative pi over 2. And we're at 1, C, we're at 0, 0. D, let's see, we're at pi over 2. And negative 1, and then we end at pi. Okay, so we just think about the new start. When we solve for x, that is the phase shift. That's shifted over horizontally by negative pi. And then the new end just helps us to make our graph, and then we can figure out, we take the start and the end and just split that into 4 equal segments. And then we put in our key points. All right, let's do one more. So we've got cosine of 2x minus pi, and our input has some addition and subtraction in there, so I know that there's some phase shift. Okay, so I'm going to need to do my start and end. It's cosine, so usually cosine, we have a start and end just like sine at 0 and 2 pi. Okay, looking at this, I can see that the amplitude is 1. There's no coefficient in front of the cosine. Now the b is 2, and so we can calculate our period. Period is the original period of 2 pi divided by b. So in this case it would be 2 pi divided by 2, or pi. Okay, now let's think about our start and our end. I'm going to take all of that, just whatever the input is. In this case, 2x minus pi, and set it equal to the original start of 0 and the original end of 2 pi. Solving for pi, or for x, we can add pi to both sides. So we get 2x equals pi. Dividing by 2, we would get pi over 2. Okay, so that's our new start, which also we can call the phase shift. Okay, and now let's find our new end. We'll add pi to both sides. So we get 2 pi, or 2x is equal to 3 pi. Dividing through by 2, we get 3 pi divided by 2. So that's our end. Now just a little trick is to think about what we're counting by. We can just count by a quarter of the period. So that's how I know what tick marks to make. So I'm going to do a quarter of the period, which is pi. So my little tick marks, I'm going to count every pi over 4. Okay. So I have negative pi over 4, positive pi over 4, 1, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is just pi, 5 pi over 4, 6 pi over 4, which simplifies to 3 pi over 2. All right, I guess we didn't need our negative there, that's fine. Okay, so we're going to start at pi over 2. Because this is a cosine graph, I'm going to start at the peak, and I'm going to end at the peak at 3 pi over 2. In the middle of that, so at pi, I'd be down at the base, and then at the quarter marks, I'd be at the midline. Okay, so here's my graph of the shifted function. And then we just label our key points, A, B, C, D, and E. All right, there we go, done. Okay, I look at the input and I see that there's some addition. That means that I know I'm going to do my start and end strategy. I see that it's sine, and so the original start and original end of sine is 0 and 2 pi. Okay, I take whatever that input is, x plus, and set it equal to 0 and 2 pi. Okay, also analyzing this graph, I'm looking at the 3. That's telling me the amplitude is 3. Because it's positive, there's no reflection across the x-axis. That 4 is going to help me figure out my period. The period I calculate by doing 2 pi divided by whatever that coefficient of x is. In this case, it's 4. So 2 pi over 4. So the period is pi over 2. And the 1 here tells me that I have a vertical shift up by 1 unit. Okay, so the first thing I'm going to do is just put in my vertical shift. I'm going to just draw that midline at 1. At y equals 1. Okay, now the amplitude is 3, and so I'm going to have to go up to 4 for the peak and then down to -2. It's sine, so it's going to start at the midline. And now we need to think about where our start is. Okay, so dividing both sides by 4, we would just get x plus pi over 2 equals 0. Subtracting pi over 2, we get x equals -pi over 2. Now that if we want to be all fancy and call it phase shift, that is our new start, our phase shift. Okay, and then our end, dividing through by 4, we would get x plus pi over 2 is equal to pi over 2. Subtracting pi over 2 from both sides, we get x equals 0. So that's our end. And let's see. Let's think about what we're going to do, what we're going to have our tick marks be worth. My tick marks, I'm going to count by a quarter of the period. So we're going to do a quarter of pi over 2, so that would be pi over 8. That is what my tick marks are going to be worth. Alrighty, here we go. Negative pi over 8. Okay, so we did negative pi over 8, negative 2 pi over 8, which simplifies to negative pi over 4, negative 3 pi over 8, negative 4 pi over 8, which simplifies down to negative pi over 2. So there's our start. We start and end at the midline. At the quarter mark, we're up at the peak. At the middle, at the halfway, we're back at the midline. And then we go back down to the trough. Okay, so here's my shifted graph. And either really make it clear on the graph what those key points are, or just list them so that it's really clear what those are.